Welcome to a new episode of IBM Z OMEGAMON AI Insights, the predictive AI that supersedes real anomalies on a curated set of metrics when static threshold creates post-positive and maintenance headache. Hi, today we're in CICS. We'll deep dive a transactional response time divergence detected by AI at the CICS region level, happening simultaneously on several regions. Let's confirm it's real, triage fast, and show the impact we avoided. So, here's the anomaly we've been notified on. Obviously, before I would say, but who diverge and from what baseline? And it's still relevant here. So, you can see here the obvious anomaly, and here's the baseline. Very fast for as response time usually. And we can see here also from the transaction count that it seems to be volume driven because we have a correlated spike between the transaction count and the response time. But in this case, I received notification from 15 regions that are slowing down simultaneously. One single notification for 15 regions at the same time. Let's see another example for you. See? Same patterns, volume driven, just a different baseline. So in this case, we need to do something else. So in this case, we need to take extraordinary measures. We need to assess the blast radius to quickly see what's the impact on the production. Because we need to decide if we need to open this case as critical and involve more people like a task force or SWAT team urgently. So let's zoom in. So now I unfiltered, I'm looking at the broader view, and I can see that from my whole production, I have here the system IDs and the regions. And from the system IDs point of view, 2 of them are impacted at the same time, and the third one is okay. If we go down, maybe for one of those LPAR, we can see that mostly all the regions, but not all of them, are impacted at the same time in terms of response time, a slowdown. If I look at the other LPAR as well. So in this case, that's confirmed, that's a critical event. We need to involve more people and it's urgent. So while the team reach out, let's gather more clues for a better context for everyone to understand better and react faster. So we can see here an important clue because we have the spikes in response time, which is here at 5, and we have the spike in CPU time, which is like about 20-30 minutes after. So it means that for a while the regions slow down, there is no work that is happening as the CPU is tailing for now. So let's look at all the KPIs. Here, the events, for example. So when 15 regions are simultaneously slowing down on only 2 LPAR over 3, we're not searching for an application bug, basically. We're searching for a shared resources that is having an issue, something that might be LC on the third LPAR, for example. So maybe when the SMEs are going to reach out, that's something that they can look at. We can see here the ABEN numbers, which is coming by thousands. So that might be also an explanation for the delays, because the system is doing a lot of dumps. And if we go look at the second LPAR, we see the second thing, and the third LPAR should be okay. So this is something those SMEs can look at as a direction already, is look at the ABEN types and try to understand what's exactly happening there. Okay, so now let's understand where the time is spent. We can see here, if we look at the average times, that most of the time is spent waiting for the first dispatch, here in blue, which if we correlate that to the other metrics, like what's happening on DB2 or the file read, we can see that nothing is happening here for about 20 minutes. So it means that something is blocking the work from happening. Nothing happened in DB2 or in file read for 20 minutes after the response time spike. Okay, so let's look further again. Now, we said at the beginning that it is volume driven and that most of the time is spent waiting for dispatch. So let's look at those specific regions for which we received a notification, how they are handling the work. And if we look specifically here at the mass task view, we can see that the transaction count is way above the max mass task. We explain again what's happening here. For about 30 minutes, there's way too much work happening compared to what the region can handle. So now let's put that in the context of OMEGAMON AI Insights, which is built for your SRE. We confirm it's a true anomaly. We assess the criticity, added more context, quickly dispatch for deeper analysis of the root cause. In that case, probably to a SWAT team for urgent action plan, because the work is stacking up. Tens of regions are not handling the load properly. This is a real customer example we are sharing here. Further analysis of ABN code, transaction names, distributions, or network would determine where the bottleneck is for the work to restart and the response time to stabilize. The beauty of that is that the AI flagged the divergence right away, but just for the specific regions that were impacted, and the alerting layer reduced the noise by combining anomalies reported in a single notification. This enabled focus, faster triage, and resolution. So in this scenario, we demonstrated that AI Insights consolidated what would be normally like dozens of disconnected warnings into a single actionable alert, allowing the team to understand the blast radius, isolate symptoms, and trigger a SWAT team response within minutes. This means for customers less downtime, faster recovery, fewer false alerts, and a better use of expert time. That's it for today's AI Insights. Earlier signal, faster triage, and better control operations. Thanks for listening, and see you in the next episode. Bye.